Hey, I thought I'd do some of the problems from 5.5 for you. There are lots of complaints about those. They're tricky problems. I think I'm going to go ahead and start with number 43. So if you have questions about ones earlier than that, just come and see me sometime. Excuse me. Okay, so 43. This is a chemical manufacturer sells sulfuric acid in bulk at a price of $100 per unit. So the price is $100 per unit. If the daily total production cost in dollars for X units is, so the cost of making those is $100,000 plus 50x plus 0.0025x squared. There's a reason why it might look kind of like this and have this big constant out front, but I won't get into that right now. Maybe just say that this, even if you don't produce, so what's the cost of producing 0 units, would still be $100,000. If that doesn't make any sense, then think about before you can produce a single unit, you have to equip your factory with all the machinery and whatever other things that you need to start making those things. So that does actually make sense that it would be like that. And if the daily production capacity is at most 7,000 units, so we're on a closed interval from 0 to 7,000 units, then how many units of sulfuric acid must be manufactured and sold daily to maximize the profit? All right, well, general principle of economics is a lowercase p here. That's just the price for 1 unit. So your profit is your revenue, how much money you're bringing in, minus cost, how much it costs you to make them. Right? That's a basic principle of economics. What we would like to do is maximize the profit. So one thing that you might notice here, and this is another basic principle of economics, is that if you're trying to maximize something, you take the derivative of that thing and then set it equal to 0. So notice that the maximum profit is going to happen when the derivative of revenue equals the derivative of cost. That's when your profit is going to be maxed out. You got to check to make sure it's a maximum. This could also be a minimum, and we don't want to minimize profit. That's not a good idea. So that's an interesting economics principle there. It's fairly obvious why that has to be true, but it's still important. Sometimes, instead of calling this derivative of revenue or R prime, sometimes this is called a marginal revenue and this is called a marginal cost. So the maximum profit happens when marginal revenue equals marginal cost. So let's see. We would like to figure out how many units we should sell to get this condition here. So the problem here, I guess, is I don't have a revenue function. So let's make one. How much money are we going to bring in? Well, the amount of money you're going to bring in is just how much money each unit costs times how many units you sell. That's all, right? If you sell X units and they cost $100 a piece, then that's how much money you bring in, 100 times X. Okay, so marginal revenue equals marginal cost, so I'm going to find the derivatives of those and set them equal to each other. So R prime of X equals C prime of X. That's when we're going to maximize profit, when marginal revenue equals marginal cost. Marginal revenue is 100. Marginal cost is 50 plus 0.0025x. 0.0050x. So doing a little bit of algebra here, so 50 equals 0.005x, so x is equal to I know my batteries are low. 50 divided by 0.005. 10,000 units. That's where we maximize that. But look, we're only capable of making 0 to 7,000 units. So the answer would be we want to make 7,000 units per day. We want to max that out, right? Would it benefit the manufacturer to expand the daily production capacity? Yes, it would, because then we could get closer to the 10,000 units where the maximum is. And part C, use marginal analysis to approximate the effect on profit if daily production could be increased from 7,000 to 7,001 units. So that's a little, I don't want to get too into that. It's a cool little economics trick that you can do. It's basically like a linear approximation type thing. So at 7,000 units, I know that the derivative of profit is this minus this. So that's 100 minus 50 plus 0.005x. And so the rate that the profit is changing at 7,000 units is 50 minus 0.005x. And 0.005 2,000, so that's 7,000 over 2. I think it's 7,000. Is that 3.5 maybe? So I think this is 46.5. Let me just check that. 0.005 times 7,000. No, it was 35. Sorry. So that's 15. So what does that mean? Well, that means the rate that the profit is changing at right here is 15. Well, 15 what? $15 per unit. So that marginal analysis tells us this is approximately the increase in profit that we're going to get for making one more unit. If we push the production up to one more unit, that'll increase our profit by 15 bucks. I am just going to do the same thing that you do here and to check my answer in the back right quick and make sure that I'm not giving you any bad information. Certainly hope that I'm not. This is number 43. So 7,000 units, yes, and 15 bucks. So that's what all that means. All right, that's number 43. That's very particular to economics, so important. Not going to see a ton of those, but it's good stuff, the econ. I got a friend up in Boston who's an economist, and whenever I go to visit him, which I do once or twice a year, he has a big desk with a giant pad of paper. Like the pad of paper is about the size of half of a lab bench, and there's always all sorts of calculus and statistics all over it, or whatever he's working on. So anyway, number 44, here's more economics. A firm determines that X units of its product can be sold daily at P dollars per unit. So X, this is the number that we can sell, and that number is equal to 1,000 minus P. This is a very crude model, right? What this means is if they charge 0 for it, if this is the price here, then they think they're going to sell 1,000 units. Well, they'd be giving them away then, right? Literally. And if they sell them for $1, then they're going to sell 999. But if they charge $500, they're only going to sell 500 of them. So it's a very strange model here, I think. But that's what we're given. The cost of producing X units per day is 3,000. That's like your startup cost, plus another another $20 per unit. And we want to find the revenue function R. So how much money are we bringing in? Well, revenue for X things is X, however many you sell, times whatever the price is. And here, I've got this weird equation that relates P and X. So if I just kind of swap the places of those, add this to that side, subtract that, then P is also equal to 1,000 minus X, just doing baby algebra there. So X times 1,000 minus X, that's my revenue function, because that's how many I'm going to sell, and this is the price in terms of X. Find the profit function. Well, profit is equal to revenue minus cost. So my profit function is the revenue function, which is 1,000x minus x squared, minus the cost function, which is 3,000 plus 20x. And you can simplify that a wee bit if you want to, but it doesn't really matter too much. So that'd be 980x minus x squared minus 3,000. Part C, assuming that the production capacity is at most 500 units per day, so that means we'd be working on the closed interval 0 to 50. Sorry, closed interval, or X is somewhere in that interval. That little sort of E-looking thing is in this set. Sorry, that's a math symbol you might not be too familiar with, but it just means X is in there. So determine how many units the company must produce and sell each day to maximize the profit. Okay, so we want the derivative of this to be 0. Right? If you want to maximize something, you take the derivative of it and set it equal to 0. So the derivative of the profit function is 980 minus 2x. So x is equal to 490 units. Is that a maximum? Sure it is. If you can make a sign chart if you want, but just looking at this is a downward opening parabola, right? So it doesn't have any minimums, it just has a maximum. And that also means that, oops, this is to be 0 to 500, isn't it? Not 50, sorry about that. Since it's a downward opening parabola, the endpoints are going to be here, and there's our maximum at 490. So you can check the endpoints if you want by plugging in 0 into this. If you don't make any units, your profit is negative $3,000, which just means you're out the startup cost for your equipment, and you didn't make any profit at all. On the other hand, you could plug 500 in here and see what the profit is, and plug 490 in. You could check all those if you want to. But 490 is the maximum. Find the maximum profit. Well, to find the maximum profit, you just need to plug 490 into this. This is our profit function. So you can do that, whatever that is. What price per unit must be charged to obtain the maximum profit? So if I know 490 units is the X, then I know the P is 1,000 minus that. So the price that's going to give us the maximum profit is $510. Right? There's that relationship there. Well, that's that one. That's your economics for the day. And let's see what we have next. 45. Oh, more economics. I need to do this one too. Maybe I'll skip that one for now and go on. I'm going to get cut off. I'm at school here, and I'm going to get cut off by the bell at some point, by the announcements in about 10 minutes. So I'm going to skip that one. It's kind of similar to the ones we just did. Number 47. Here's a one that's a little different. So I've got two particles A and B, and they're in motion in the same xy plane. Their coordinates at each instant of time t greater than or equal to 0 are given by the x-coordinate of the A particle is t, the y-coordinate of that particle A is 2t, the x-coordinate of the B particle is 1 minus t, and the y-coordinate of the B particle is just t. And we want to find the minimum distance between A and B. Okay, so I'm trying to minimize distance. So that means I need to have a distance function, and then I want to try to minimize it. So I'm going to take the derivative and set it equal to 0. So the distance formula is basically the Pythagorean theorem. So that's the square root of this minus this. So this minus this, that would be 1 minus 2t squared. Right? That's x minus x squared. It doesn't matter the order you put them in because we're squaring it, so it comes out positive regardless, plus 2t minus t is just t squared. So there's my distance function, and I need to take the derivative of that. Since I need to take the derivative, I think it's probably worthwhile to simplify that. So I'm also going to write it in more calculus-friendly notation. So foiling this out, that's 1 minus 4t squared, sorry, minus 4t, excuse me, and then plus 4t squared, but I got another t there, so plus 5t squared, all to the 1/2. Now I would like to minimize distance, so I'm going to take the derivative of this and then set it equal to 0. And I know how to take derivatives. Do you? Hope so. Now, I would like to set this equal to 0. Now, take a look at this. It's already in factored form for us, so don't go crazy trying to simplify this now. I need one of these factors to be equal to 0. This is just a constant, can't be equal to 0. This is actually on the bottom of this thing, so if you've got something on the bottom of a fraction, you can't use that denominator to make the fraction 0. If this happened to be 0, that would make it undefined. If you have a fraction and you want it to be 0, then the numerator has to be equal to 0. So this is the only piece that has any chance of making the derivative equal to 0. So that would be t is equal to 0.4 seconds. Is it time in seconds? Did they say that? They didn't say, but we can assume that it's in seconds. And we want to find the minimum distance. So this is the time that gives us the minimum distance, but the actual minimum distance is what you get when you plug 0.4 into this. So the distance between them at time 4 is the square root of 1 minus 2t, so that would be 0.2 squared plus 0.4 squared. And I don't know, I mean, you could try to get some kind of exact answer there, but let's just see what that's equal to with the calculator. Square root of 0.2 squared plus 0.4 squared. That's rounded to 3 College Board decimal places. That's 0.447. And this is an odd numbered problem, so we can check our answer. Let's see if that's right. Number 47. Oh, they have the exact answer. They have 1 over the square root of 5. So let's see, 1 over the square root of 5. Wait for it, cross your fingers. Oh, snap, that's it. Okay, so good. Number 40, let's see, what's 48? 48 is really similar to that one. You can try it, works just like this. 57 looks a little different, so let's do that one. 57, where on the curve y equals 1 plus x squared to the negative 1 does the tangent line have the greatest slope? Okay, so think carefully about what we're trying to do here. I want to know, where does this thing have the greatest slope? That means I'm trying to maximize the slope. I want to find the maximum of the slope. In other words, I want to find the maximum of the derivative, or in other words, the maximum of y prime. So if you want to find the maximum of y prime, then you have to take the derivative of whatever you're trying to maximize and set that equal to 0. So I really need to set the second derivative of this equal to 0. If that's confusing to you at all, you need to slow down here and think about that very deeply, what's going on here. If you're trying to find the maximum of whatever, then you need to take the derivative of that thing and set it equal to 0. So if I'm trying to find the maximum of y, well then I'll just find the derivative of y, but that's not what I'm trying to do here. I'm trying to find the maximum of the slope. So if you want the maximum of the slope, you need to take the derivative of the slope, in other words, the second derivative, and set that equal to 0. So let's try to do that real quick. So negative 1 plus x squared to the negative 2 times the derivative of what's inside. Second derivative, I'm going to use, I'll call this the first and this the second, because it's a product, so I have to use the product rule. So the derivative of the first is 2 times 1 plus x squared times 2x. That's the derivative of that, times 2x. That's the derivative of the first times the second, plus the first, which is negative 1, oh sorry, negative, sorry, I didn't really want to write that 1 there, did I? There. That's what I want. Maybe I'll make that square brackets just to make that more clear. So this is the first times the derivative of the second, which is that. All right, let's see what I can do. I need to set this equal to 0 and simplify, see if I can do any factoring. So, and I forgot to put the exponent there. That's to the negative 3 now, right? Okay, so what do these things have in common? My advice to you is when you have some factor in common, factor out that thing to the lowest power, right? The most negative power. So that's going to be 1 plus x squared to the negative 3. I've also got a 2 in common that I could factor out, and that looks like that's it. So what's left behind here? I factored that out, I factored that out. I've got 4x squared, and then here minus, and then when I factor out x to the negative 3, the thing that would have to be here would be one of those to the first, and the 2 is factored out. All right, so similar to what we did in the last problem. Ooh, look at that, there's some old limit stuff peeking out there. Don't look at that. Or do look at that if you want. So, this is already in factored form. So this, well, that's a number. That's not going to be equal to 0. This, that's in the denominator, so that can't make this equal to 0. So it's got to be this thing that makes it equal to 0. So let's see, that's 4x squared minus x squared. That's 3x squared minus 1 equals 0. So x is equal to plus or minus the square root of 1/3. And, well, gee, I think that's it. Except that I think this, we want to know where it has the greatest slope, and these are places where the derivative is 0. So these could be maximums or minimums. So I think I best make a sign chart here to see which one is the maximum or what's going on here at all. So when I plug 0 in here to figure out, this is my sign chart for y double prime, right? The derivative of the thing I'm trying to maximize. When I plug 0 in, I'm going to plug it into this because this is in a simplified form. I get 2 times 1, and then this thing here, which is equal to 3x squared minus 1, that's negative. So this is going to be negative here. And then, oops, sorry, that was 0, wasn't it, that I just plugged in? So that's where the negative is. If I plug in a negative number, like this, the square root of 1/3 and negative 1/3, that 1 is outside that. So if I plug in 1, that should be a fairly easy number to deal with, I hope. So if I plug in 1, that gives me positive 2. This number is always positive. And then if I plug in 1 into this, 3 minus 1, that's also positive. And if you check over here, this is also positive. So if I'm looking for a maximum, that is going to happen here. So the maximum slope is at x equals negative square root of 1/3, because the slope, the derivative of the slope, which is y double prime, goes from positive to negative. And just check that real quick. I feel pretty good about that. That was number 57. Number 57. Yep. Oh, did they want the actual point? Where on the curve? Yeah, so you can plug that in. And there's the announcements. We're done.